So in this video, I want to go ahead and talk about what we call the normal distribution. All right. And so you have these notes, and we're going to go through and fill out these notes. But I want you to understand the normal distribution is essentially what we call the bell-shaped curve. And the way it works is in this particular bell-shaped curve right here, most of your values are going to fall at the center of the curve. And these are the more typical values. And now you start to move away from the center. Notice that what happens to the frequency of the distribution. It starts to tail off this way to the left, also tailing off this way to the right. And a lot of things that we measure, such as your height, such as your weight, are normal, which means that there is a normal height for people or a normal weight, an average weight that falls here in the middle. And then you have some people that are either very short or very small. Some people that are very tall or very large sit out here. So we start this off by saying, what is it? And the normal distribution is it's a continuous distribution because we're talking about measurements. So it's a continuous distribution that is two things. It's always going to be unimodal and bell-shaped. Unimodal means that in this particular distribution, remember a mode is how something repeats. Well, it's repeating the most in this area right here. And because of that, it's going to produce this bell shape because we're moving away from them. So it's a symmetric distribution. And remember, in the symmetric distribution, the mean is always going to be equal to the median. And we can define every normal distribution by two population parameters. Remember, your parameters are just your true values. So we have two true values for this. And those two values are the mean and the standard deviation. And so what happens now is, if you know the mean and the standard deviation, you know everything about the distribution. And in particular, because it's symmetric, the mean and median always sit in the middle of the curve. So it's symmetric and bell-shaped. This means that the mean, and remember we call the mean the population mean, we call that mu. And underneath this curve are places where the curve starts to drop at. So it drops here and here. And that's the same distance from the mean. Then it drops again from here and here. And then it drops one more time from here and here. And in this particular curve, there are, if you look at this then, from this side to this side is 3 standard deviations, 3 sigma. And then from this side to this side are 3 standard deviations, or 3 sigma. And so that gives you a total of 6 standard deviations to the left and right. And there are 3 standard deviations to the left, 3 standard deviations to the right. And the most important thing that you need to realize about this curve is that this axis, the tails themselves are asymptotic, which means that an asymptote means that it'll approach this line but never touch it, just like it'll approach the line, never touch it. So this tail goes to negative infinity, and this tail goes to positive infinity. So your tail on the left, the tails of the distribution extend to negative infinity on the left and positive infinity on the right. And then this leads us to the most important thing about what we're going to use this curve for is we're going to use this curve to find the area underneath certain parts of it. And we're going to treat this like it's a probability. And because we have 100% of the data underneath the curve here, because there's 100% of the data underneath this curve, we can say that this is the same thing as being equal to just 1. Or we can also call that 100%. But we're going to treat it and allows us to correspond the curve to probabilities.